All right, so today deals with chapter 3. It's vectors. Again, if you are not comfortable with your voice being recorded or things you say being recorded, please just send me a chat and nobody will know it was you. And then I'll read the chat and we can go over it. But when we talked about vectors previously, we said vectors have magnitude and direction. Oops, that's not how you spell it, but do they have magnitude and direction? So there's two things. And with our vectors are essentially going to be drawn out on our Cartesian coordinate system. So we'll have first quadrant vectors, second quadrant vectors, third quadrant vectors, fourth quadrant vectors. These vectors will have what we call components. So this is our positive x component of that vector and our positive y component of that vector. This would be our negative x component, and this is our negative y component. This is negative x. Oops, this is positive y. Sorry. This is negative x, and this is negative y. This is positive x and negative y. So in blue, we have what we call components. And these are one-dimensional, and they lie on x and y axis. So today what we're going to learn how to do is solve for vectors or resultant vectors. Resultants, that's another key vocab term. Resultants are one vector that represents multiple vectors. So a resultant is going to, let's just say, if we walk east, and then we walk north, and then we walk west, and then we walk north again, those are all of our individual vectors. So we'd 1, 2, 3, 4 individual vectors. Our resultant is going to go from start to finish. That's R, and that's in our first quadrant. So it's angle theta. So a resultant is one vector that represents multiple vectors. You can see our resultant here is going to be made of a hypotenuse. It's going to have components. Here's our x component, and here's our y component of our resultant. And this is what we're going to work on Thursday, trying to figure out these multiple vector situations. But today we're just going to learn out the basics of how to find resultants. So finding resultants. Let's say we do that problem where we walk 5 miles east, and then we walk 8 miles north. Now, how are we going to find our resultant vector? The first thing we do is draw vector triangle. And it's always a right triangle. We draw our x component first, then we draw our y component, and then we draw R. So we draw our vector triangle, then we draw our x. So we drew our 5 miles, and you can see there are arrows that represent our vectors. Then we drew our y component, so we went up 8 miles, and then we drew our resultant vector. Our resultant goes from start to finish, and there's an angle theta. So our third step is to draw R. So we draw our vector triangle, first thing we want to do. Next thing we want to do is solve R. And to do this, we use our Pythagorean theorem. We're always going to have right triangles. R squared equals x squared at y squared plus y squared. So over here we have r squared equals 5 squared plus 8 squared. R equals, or I should say, where's my, R squared equals 89. R equals the square root of 89, which is 9.4 3 miles. So we solve for r, then we solve for our angle. And we are always going to use tan theta equals y over x. This angle theta is always adjacent to x-axis. So back, the other picture I drew with the resultant in all 4 quadrants, the angle theta was always measured adjacent to the x-axis. So this is our x component. Our angle theta is always measured off of that. So we can always use tan theta equals y over x to solve for our angle. Tan theta equals 8 over 5. Theta equals 58 degrees, 58.00 degrees. And then our final step is to write out resultant, including quadrant. And this is hard to do on my little pen system, but we say R equals 9.43 miles at an angle in the first quadrant of 58.00 degrees. This is called magnitude angle format. And that's how you solve for resultants. It's fairly easy. We're going to do this a lot, especially through chapters 3, 4, and 5. So it's a skill we need to learn. So this is what we're going to practice for a while. We're going to practice solving resultants. I'm going to do another one with you without all the writing. Go slower, show you how it's done. Does anybody need anything clarified before I move on? I don't see anything in the chat, so let's take a look at another problem. Let's say we're going to do this. I don't know. We can do anything. We have 7 meters per second and so bad, 11 meters per second. Those are our 2 forces, or 2 velocities. Those aren't forces, those are velocities. And we want to find the resultant. So the first thing we do is draw out our vector triangle. So we draw our x first. Then from the head of x, we draw our y. We always want this to be a right triangle, although it doesn't look like it in that picture. And then we draw r from start to finish. And there's our angle theta off the x-axis, adjacent to the x-axis. Now we solve it. R equals 13.04 meters per second. Then in the y direction, tan theta equals y over x. (32.47 degrees). And then we write out our answer in magnitude angle format. R equals 13.04 meters per second at an angle in the second quadrant of 32.47 degrees. And there we go. That's how we solve this problem. Anybody need anything clarified there? Okay, so we are going to try one on our seats, or try a couple at our seats, not just one. First one, I'll put 2 here. Let's do 5 meters. Let's just do 1 here for now. 5 meters. Let's do 15 meters, make the numbers a little bigger. And 19 meters. So at your seats, try to find the resultant for this situation. And then when you're done, put your thumbs up. And to find R, first thing I'm going to do, draw my vector triangle. Oh my goodness, it's so hard to draw downward vertical on this thing. Oh, it's so much better. Draw my vector triangle. I can see it's in the 3rd quadrant now. So R squared equals 15 squared plus 19 squared. I got 24.21 for R. And tan theta equals 19 over 15. 51.71 degrees. R equals 24.21 meters at an angle in the 3rd quadrant of 51.71 degrees. Anybody need anything clarified there? We left. Who left? All right, so any questions? Let's try another one. .21 miles and 6.10 miles. Give that one a whirl. So again, make sure we're drawing these vector triangles out. I got R to equal 6.89. And theta to equal 27.76 degrees. And that's our answer. Anybody need anything clarified there? All right, so that's finding resultants. Next thing we want to do is learn how to find components. So we only have 4 choices for our components. We can have a 1st quadrant, a 2nd quadrant, a 3rd quadrant, and a 4th quadrant force. That gives us a positive x, like we said before, a positive y, negative x, negative y, or positive y, negative x, negative y, positive x, negative y. Those are the only 4 options. We always measure our angle adjacent to the x-axis. So this is our resultant side, this is our adjacent side, this is our opposite side. So to find the adjacent side, cosine, I can call this the hypotenuse, so that makes it better. Cosine theta is the adjacent over the hypotenuse. So to find our adjacent side, we're always going to use cosine. So I'll write it out on another piece of paper. So for x, we always use the formula r cosine theta. And for y, we always use the formula r sine theta, because we're always having our angles measured off the adjacent axis. If you switch that around, then you got to switch around the sine and cosine. But if you keep it simple, always have your angle adjacent to the x, you can always use these 2 formulas. So these aren't very difficult. This is something, again, you have to master because we're going to use it all the time. So if I have this resultant here, 15 meters per second at an angle of 60 degrees, I again draw my vector diagram. This is y and x. X will equal r cosine theta, 15 cosine 60, 7.5 meters per second. And y equals r sine theta, 15 sine of 60, 12.99 meters per second. So this is how we do components. Pretty simple, but you got to be good at it. Now, one thing I forgot to mention is that this x has to be negative. This is key. You have to make sure that you have the right signs. This is going to the left. And one thing we have to make sure, since these are vectors, that they have a direction. X is going to be negative. So what I'm going to do is give you guys one to do. R is 450 kilometers at 67 degrees. Give that a try. X equals 450 cosine 67. X equals 175.83, and that's positive. Oops, I forgot to draw my triangle. That's what our triangle looks like. 175.83. Kilometers. And then y is 450 sine of 67. Y is negative 414.23 kilometers. Anybody need anything clarified there? All right, let's try another one. Heart of red, going to a different color. There's only so many colors in this palette. $5,000 meters per second at 50 degrees. We go with all 5s and 0s. Give this a try. We have x equals 5,000 cosine of 50. X equals 3,213.9 meters per second. That's going to be negative. And y is 5,000 sine of 50. Y is negative 3,830.2. meters per second. And I'm only using one decimal place here because that's all my calculator goes. It's in scientific notation. That's a point right there. How about that? Do we have any questions on that one? Now what we're going to do next time, and I want you to watch the video prior to next class because we have a lot to go through, but I'm going to stop recording.